So hello everyone, my name is Nitin Teja and I'll briefly explain the program for the smart health monitoring system. So what you're looking at right now is the final code that we've used in the project. It has been divided into three parts, just like any other Arduino program. The first one is where we declare all the variables that we're using in our system. The second one is the setup system, and the third function is the loop function, which will actually do the work. So let me briefly walk you through the code. So we are basically using two sensors in our project. The first is a pulse sensor, the second is a temperature sensor. So in order to measure the signals from the pulse sensor, we have downloaded a library which was recommended by the manufacturer called the pulse sensor library. It will inform the Arduino board to collect the signals from the pulse sensor and then channel the signals to our system where it can interpret that signal as a heartbeat. So this is the pulse sensor playground.h, which is a file, a library that we have uh, downloaded online. So from there we have to modify the code so that it can measure our heartbeat. The second thing is the temperature sensor is pretty straightforward and we've written the entire program from the scratch. Okay, so I've also added some comments on the right side so you can understand what is going on inside the program. So this entire part is basically just declaring the variables for the pulse sensor. Just uh, just telling it what kind of pins that we're using in the Arduino board, etc. And the next variable is int buzzer equals 11. This is basically because our buzzer is connected to the pin 11 of the Arduino board, and from the next line all these variables are for the temperature sensor. And as you can see, we are using the pin A2 so that it can send its signals, analog signals, to the A2 pin to the Arduino board. And then after the temperature sensor, these variables are for the LEDs. So these are basically how we have defined the connections for the LEDs. So basically we are using 6 LEDs, 3 for each sensor. So how they work is, if one of the parameters recorded by a sensor is out of range, for example, if I'm measuring my temperature and it's higher than what it's supposed to be, then on the 3 LEDs that are being used for the temperature sensor, one of them will be red, one of them will be green, and one of them will be blue. The same goes for the heartbeat sensor. So if my temperature is higher than what it's supposed to be, it will make the red LED glow. If it is within the normal range, it will make the green LED glow, and if it is below the normal range, it will make the blue LED glow. And the same analogy works for the pulse sensor as well. If the pulse sensor's reading is above, if my heartbeat is above what it's supposed to be, and if the pulse sensor detects it, it will generate a signal that is channeled through pin 7 to the LED so that it can make the red LED glow, and so on. So this is the end of part 1 of the code, and the part 2 is basically the setup function. And how it works is, the first 6 commands are basically the pin modes for the LEDs. It will just signal the program that we are using LED. We are basically using these pins in the Arduino board, and we are using them as output. So the Arduino board will generate them as outputs. One second. The next. So this is the baud rate for the serial monitor. Yeah, so this is the baud rate for the serial monitor. This command. One second. So nine. Oh my God. Yeah. So this is the baud rate for the serial monitor. And the next three functions are from the pulse sensor library. They will basically channel the analog output signal, and there we have to write the code on how are we scaling that signal to our BPM. So that is the end of part 2, and part 2 was the setup. Now comes the loop, and this is where the actual work goes on. So part 3 has been divided into two parts since we're using two sensors. The first part is for the temperature sensor, the next part is for the heartbeat sensor. So for the temperature sensor, yeah, yeah. So these commands are for the temperature sensor. The first is the float variable and the float sensor variable, which is of the float type, and it is basically the signal which is being uh, acquired through A2 pin of the Arduino board. And this is basically how we are scaling the signal, and this is the raw temperature that we are detecting from the signal. So the problem was that the signal was very inaccurate and very inconsistent. So for the sake of demonstration, we had to tweak the code a little bit. So what we have done further was that we have added these two lines. So in addition to writing that code, what we found out was that the signal was very inconsistent. So we have defined two new variables. The first one was the variable y, and variable y is basically defined as temp c divided by temp c plus 0.1. So our objective was to obtain different numbers, but numbers which don't have significant amount of variance and numbers which fall within the normal range of a temperature. So what this does is it will, anytime the temperature is detected, it will be a new number, right? Because the signals will not be the same every time, so the temperature keeps on changing. So as the temperature keeps on changing, y, which is a function of the temperature, is also changing. But y is defined as temp c by temp c plus 0.1, which is basically a number that is close to 1, a number that is close to 1, but that is also but a number that is also continuously changing since temperature is changing, but nonetheless a number close to 1. And since the human body's temperature is around 37 degrees Celsius, we have multiplied it with absolute value of y, and we have taken the absolute value because what we found out was if we were not taking absolute value, we were getting the temperature in negative 20 degrees Celsius, which is obviously untrue. So we have taken the absolute value of y, which is close to 1, and then we've multiplied it with 37. So what it does is that it generates temperature measurements which are close to 37 and yet that are changing and that don't have a high degree of variance. And the next lines is how we are printing the code, printing the strings on the serial monitor. So this is all intrinsic within the program. It happens inside of the computer, which will not be able to see. The only thing that we will be able to see is the one that we have defined in the serial print command. So basically, once it has made the measurement, once the temperature is ready, what it will say is it will print the command temperature in Celsius. Then it takes a new line and it will print the absolute value of P, which is the temperature that we have defined in Celsius. And then it takes another line, and then it prints temperature in Fahrenheit, and then it prints the temperature in Fahrenheit using this formula, which is a dependence, the linear dependence between the temperature values in Fahrenheit and Celsius. So up until this part, what it does is basically measuring the temperature and displaying it on the serial monitor. After that is done, now that we know what the temperature is, we want to make sure that it is within the normal range so that the person can be alerted to if it's not. So the first command is this block is executed only if the temperature in Celsius is less than 35.2. So if the temperature recorded is less than 35.2 degrees Celsius, so if the temperature is less than 35.2, it will first generate a buzzer tone for 500 milliseconds. So up until this point, it will first record the temperature, it will display the temperature, and then it will generate a buzzer tone. After the buzzer tone is generated, it will blink the blue LED light. Because the temperature is lower than what it's supposed to be, it will blink a blue LED light. And if the temperature is higher than 37.8, which is the upper limit that we're using, then the buzzer will generate a tone again because it is not normal. So every time you hear a buzzer tone, it means that it's not normal, and then it makes the red LED glow for 500 milliseconds. So the LEDs basically tell you whether it is high or low, and buzzer tells you whether it is normal or not. And if the temperature is normal, everything is fine. It will make the green LED glow for 500 milliseconds, which signals you that your temperature is good. Your temperature is good. So up until this point, this is basically recording the temperature, displaying it on the screen, and then signaling to the user if the temperature is right or not. And the next part is for the heartbeat sensor. So this we wrote these commands after we've learned how to do it, and what we found out was the same problem that we found out with the temperature sensor, was that whatever raw beats per minute, that is the raw measurement that we were getting from the pulse sensor, were highly inconsistent, and they were highly out of range. So, I mean, the first signal, I mean, one of the readings that says 120 BPM, which is pretty high, and the next reading itself, it was showing us 30, which was pretty low. So we use the same trick again. We've declared another variable, which is x as my BPM by my BPM plus 5. And since we were getting the my BPM values in hundreds or even 30s, it is still a number which is close to 1, but yet a number that is changing. So since x is changing, it will generate values which are closer to 80, and we only did this for the sake of demonstration, because we explored various ways on how to solve this issue, but we couldn't we we weren't able to do that. So after multiplying it with x, it will generate the BPM, which is close to 80, but also tells us whether it is high or low. So once it has recorded the heartbeat, it will now print the strings on the serial monitor. Oh, yeah, yes. So it will now print. So after it has evaluated what the heartbeat is, it will now say heartbeat found, and this is your BPM, and then it prints the value. And the same we have and it's basically the same system as that of the temperature system. If the heartbeat is less than 60, it will generate a buzzer tone and make the blue LED glow. If it is greater than 100, it will make the red LED glow, it will generate a buzzer tone, and if it is within the normal parameters, it will just make the green LED glow. So ideally, if a normal person is using it, he should just see the green LEDs glowing one after the other, because only then both his parameters will be normal, and if either one of them is abnormal, then our buzzer signal will be alerting the fact. um, okay, and this command is basically when you don't place your finger on the pulse sensor, it just says no pulse detected. And that is it for the program. Okay, so thank you for staying with me. My name is Nitin Teja, and I'm a part of the Smart Health Monitoring System group. Thank you.